Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be building a time-lapse video recorder. It's a great little project with a Raspberry Pi 5. But before we get into it, be sure to hit that like button, and if you haven't subscribed, please subscribe. But let's get right into the project. Okay, so pretty much the time-lapse recorder is just going to be downloading individual JPEGs every second, and at the end of every hour, it will automatically make an MP4 file, which is H.265 encoded using FFMPEG to turn it into a video. So it's just going to be a series of still images, and then the output is going to be a video. And some reasons this could be good is, if you want to capture security cameras or do screen captures, for example, and just be able to track it over time without actually watching it in real time, this is a great way to do it, and really can be used for anything where there's a URL that has a JPEG image that will update frequently. So it's just got to be one static URL. But once you have that, if the image underneath it does update, then it's good to go. So some of the particular features of this script is that it's easy to install and configure, and we're going to go through the installation today. And I do already have the link posted inside of the description. Just read it down below. But pretty much it's just a set of files that we need to install and a little bit of configuration, and we'll be up and running. Then the output, as I said a second ago, is H.265, so it's going to be very space efficient, and it's going to be wrapped in an MP4, so you should be able to play it most anywhere. And the files that are going to be output are going to be organized by date and time, so in the folder structure itself should be very easy to navigate. And of course, because it's storing this to a hard drive, it is video, it does need a way to make sure that it's not going to fill up the hard drive, so it is going to keep track of that, and as the hard drive starts to fill up, you set the percentage that you want it to, and it will delete the oldest files automatically. So that way it can record theoretically forever. But doesn't do any good if you can't access it, so of course these files can be accessed through SFTP or an SMB share that's password protected. So that way not just anybody can go in and look at your files. So we're going to be using a NVMe to actually store the files here. Ignore my finger. But we're going to be using an NVMe to actually store the files. It doesn't matter what size it is. I'm using one of the new Raspberry Pi 5 NVMe hats. So it is going to be very fast. And that's going to be very useful because obviously it's going to be writing at the same time that it's transcoding. And potentially serving files as well. So we don't want it to be the bottleneck. And we definitely don't want to use a spinning disk for this. It'll, I think, just drag down the process. But this definitely, based on my testing, has not provided any bottlenecks at all. It's been very good, even though it's all going to be working off of the same drive. So first thing that we're going to do is we're going to be encrypting this drive. Now, specifically, we're going to be using BitLocker. And I know people are saying you could use Lukes and do the same thing. But in this particular case, I want to be able to recover it easily. And it's easiest to have, I like the way that BitLocker operates in terms of being able to be accessed from any Windows machine with no real special software or configuration required. You just enter the password and it's recognized as USB on the go. So what I'm going to do is I'm going to put this inside of an external NVMe enclosure. In this case, it happens to be a Sabrent drive. I do like this particular enclosure because it's toolless. But I'll secure that in there as a little integrated heat spreader, whatnot. And I'm going to plug it into the machine really quick. So now that it's connected, we're going to go in and we're going to clean the drive, okay, using Windows. So we're going to open a command prompt. We're going to do disk part. Do the confirmation to escalate privileges. It opens it up and we're going to do list disk. Now we see two disks here. One's the internal drive. We don't want to do that one. The other one is disk 1. That's the one we want. So we're going to do select disk 1. Now it's selected, we're going to type clean. And pretty much what that does is it erases any kind of partition or file table associated with it. You saw how fast it was. It's just erasing the file table. So that way it looks like a factory drive. You know, there's no existing data on that. So just be careful. Don't use a drive that you care about, because a lot of the processes that we're going to be doing here are going to go ahead and delete those things. So we're going to do disk part, and we're done with that, so we can do quit. Or actually, exit. And we'll do exit again. All right, so now we have an uninitialized drive. So we're going to open up Disk Manager. I'm going to misspell it, but Windows is still going to figure it out. And it's going to ask me to initialize this new drive, because again, we haven't actually put a partition table on it. We just cleared off everything that was on it. So we're going to choose GPT in this particular case. We could choose MBR, but just remember you're limited to about 2 terabytes. So even though it's a smaller drive, it's only about 500 meg, I'm still going to do GPT because that'll apply to most use cases. And again, it doesn't matter. GPT supports every drive. It's just newer. So now that we have that, we have no partitions on this particular drive. So we're going to right click and do new simple volume. And actually I spent a bunch of time building a thing to zoom in so everybody could see this. There we go. So now we can go through, set the defaults. We're just going to use the entire drive in this particular case. We're not going to partition it down, although we could. We're going to assign a drive letter, but that's only going to be useful for like 5 seconds while we get it set up for the BitLocker. And we're going to format the drive. In this case, we're going to use NTFS. And for BitLocker, I do suggest using NTFS, not exFAT. And we're just going to call it Timelapse. And we're going to do a quick format with the default allocation unit size. We're going to hit finish, and it's going to format it. It's going to open it. Perfect. So now we have a drive that is able to be written to, but we want to encrypt it. So that way, if somebody does take our Raspberry Pi, unless they know the decryption key, they're not going to be able to go in and read it. So they'll actually have to know something. It won't just be something where they can, you know, take it apart, sell it, and somebody could read all of our files or see our security cameras or something else like that, or see our screen shares. So we'll close out of that really quick. We can close out of disk management, and we're going to open up BitLocker. So we'll do manage BitLocker, and we see I have it on for my C drive, but for the D drive that we just formatted, it's turned off. And actually, let me zoom back in and move this over. So we see it's currently off. Let's see if I can make this the exact size. Just, I think it's going to be easier to read. All right. So right now it's turned off. I'm going to hit the down arrow, and we're going to turn it on. All right, and it says, how would you like to unlock the drive? In this case, we're going to use a password. I'm going to type in a secure password, and actually, right, so I typed in secure password. You put in whatever password you want, make sure it is secure. You can use smart cards as well, but that we're not going to cover that here. We are going to use a password to unlock this on the Linux machine. Okay. We're going to hit next. It's going to ask you, do you want to back up your recovery key? Always back it up to as many places as possible. I always encourage printing it as well, just because that will mean that you will have a hard copy. So in the event that you forget what the actual password is, you at least have a path to be able to recover the data that's on it. So do all of this. I'm not going to do it. I'll print it because it's going to make me. So it won't let you hit next without doing something. And then we're going to hit next. And my printer's probably going to turn on. but that's okay. So in this particular case, we have two options. We can encrypt the used disk space only, which if you have a new hard drive, that's a good option. That's totally fine because everything's already going to be zeros. Normally for this situation, since we just cleared this drive, we would encrypt the entire drive, but that's going to take like an hour. So I'm not going to do that for the purposes of this demo. So there's two options here. So there's Windows 10 introduces new disk encryption. And for us, that's totally fine because it did actually predate this. We're going to do the new encryption mode, which is perfectly fine for this. And it's a bit more secure than the older mode. And we're going to start encrypting it. Right, and we see it's complete. So we're going to close out of that. This is now ready to go. So we're going to close out of BitLocker, and I'm going to eject the drive. So I'll go down here, look at the little USB icon, and eject it safely. It's important to do that now because then otherwise it could corrupt the drive. You know, it's open with encryption, things like that. So just be wary of that. So now that it's actually ready to go, let's unplug it. I can go back over here to the camera. I'm going to push the little clip here and pull the drive out. Put it to the side and reinstall the NVMe in the Pi itself. Right, so now it's ready to go. I previously created a Alpine Linux SD card that actually has our operating system on there. It's completely vanilla. It is exactly the way that it's downloaded from the website, just extracted to FAT32 format. A question was actually brought up recently inside of one of the comments of one of the other videos, one of the previous videos, where it was asking about the FAT32 format. If your drive is over 32 gigabytes in size, you do have to do exFAT. So if you want to be able to write to it from Windows, you have to do exFAT as your format. There are other options. You can also do the ISO, but you won't be able to write to the root partition, which may make it difficult depending on your situation. So just something to keep in mind. I tend to use 32 gigabyte SD cards just because that has always been more than enough for anything that I'm doing on Alpine Linux, since generally it's all dependent on RAM anyway. So I'm never going to be using that much, or at least haven't to date. So it is something where I'll usually use a secondary storage device if I'm going to use something that's very storage intensive, so I don't risk corrupting the actual OS drive. So just wanted to say that. So just in response to the comments, I put it in there as well. But always feel free to ask if you ever have any questions about anything that we're covering in any of these streams or videos. Definitely feel free to ask. I try to answer everything, and in a relatively timely manner too. So let me go ahead and get this connected, and we'll get this booted up so that way we can start looking at the installation. And I actually ended up having to run a special network connection for this in order to make sure that I could access the test location. So hopefully that all works out. All right, so we'll go through the instructions here. And I have this again on the GitHub, but we're going to install some programs. We're going to copy the files over from the root folder. We're going to set up our SMB share and set up our users so we can access it. We're going to build from source DiskLocker, which is the Linux BitLocker utility. So we're going to build it from source from their GitHub in order to install that and use it. Then we're going to make sure everything is all set to run with executable permissions. add the Timelapse loader process service to start by default, and then add all of the files to LBU so they're preserved past reboots. Do some access restriction for things that contain passwords and things like that. And it is something I was looking into doing like Pass or one of the other utilities that you can install for Alpine Linux or Linux generally in order to store secrets in an encrypted format. This doesn't have that. It was a bit too much to get into for this particular dive. So there may be a future version coming out where we'll actually cover something like that. And then just going over a few configuration examples here, just to cover exactly what we need to get it up and running. So that's what we got. So let's take a look at our what we just booted into with our Pi. Hopefully it actually has some video. There it is. And we have to get this initially configured so we have network access, because the rest of this we'll do all through PuTTY. There's no UI or anything else like that, but obviously right now it's just local, so we got to configure it through something. So let's go ahead and log in. Default is root, so we're going to do setup Alpine, and this will take us through. And another question that came up in the comments of one of the videos recently was, if you mess up, you can always just rerun setup Alpine at any time, and it will overwrite any of the settings that you put in there. So if you make a mistake or you want to change something, just rerun setup Alpine. It won't hurt it a bit to run it a second time, or third, or fourth. So I'm going to do US for the keyboard. That happens to be the case for me. I'm going to call it Timelapse for the host name, and we're going to set up the network. So I'll do Ethernet 0. I'm going to do DHCP in this case, and no wireless LAN, no changes. And we'll see what IP address it comes up with. In this case, it's 140. Perfect. I'm going to give it a very secure password. And I'm going to set the time zone. I'm not going to use a proxy. We're going to set up the NTP, which of course it's going to need NTP because it's going to be setting up the folder structure by date and running things based on the time. So it needs to be accurate. We're going to be using Crony for this, as we usually do. And the default server for ntp.org is perfectly fine. And we're going to set up our APK mirror. We are going to enable the community repository and just choose the first mirror option. We're not going to set up a user right now. We will set it up later. It's just got some special flags just to make sure that they can't log into the shell. But we'll use OpenSSH to be able to log in through SSH. And we do want to allow root login because that's how we're going to configure it. So we're going to type yes here. Remember, for production, you don't want that to be, or you want to use a key in order to access it. So you would want to leave prohibit password, but we don't care in this case. So we're not going to do a disk install. We're going to use the memory card to store all of our configs and our cache. And it gave us a warning, but doesn't matter. We're going to do APK update, make sure everything goes, and now that warning is null and void. It doesn't really matter. So excellent. So let's do LBU commit-d, save that out. Now we should be able to log in through SSH. So if we switch back over to our computer, I'm going to open up SSH. Perfect. So we're in. So now we're going to be following what is on our screen in terms of the installation instructions. And let's see if we can make this show both at the same time. Looks kind of messy, but that's okay. Alright, so first thing that we're going to do is we're going to install this. So these screen core utils, which has wget in there, which is actually how it's retrieving the file. TZ data, which is for setting time zones that are different. It will automatically update that for you based on how you configure it. Crypt setup, and some other things, which are pretty much part of encryption. Samba is for the file share, Fuse, NTFS, all of that. So we're going to copy that out, paste that in, and let that run. Perfect. So very fast. Now, something I do want to just take a look at really quick. Let's make sure that our NVMe drive is actually showing up. So let's do lsblk, which is part of what we just installed. Oh, it wasn't. So we'll do apk add lsblk, which I need to add that. I'll upload that to the Git and make sure that's up to date. We'll do lsblk, and it shows that we do have the NVMe drive recognized. And we see it has 2 partitions, but that's perfectly fine. So just in case you don't see your NVMe recognized, you may need to actually update your bootloader. And the way that, it's something where pretty much a lot of the Pis that are still for sale are the older bootloader, which has a lot of the features but doesn't have NVMe enabled by default. So what I usually do is I will download, using the Raspberry Pi Imager, a current version of the Raspberry Pi OS, run it, and do an update on the actual system itself once booted into the desktop. And that will automatically update the bootloader to be able to support NVMe. And then pretty much you can shut down, remove that SD card, reformat it as Alpine Linux, and be able to use it, and NVMe will be recognized and even boot off of NVMe if you wanted to, for using Alpine Linux or anything else. So just a quick caveat, just in case that does come up. You want to make sure that you're not running into trouble and beating your head against a wall saying it doesn't work, but meanwhile the bootloader is old. So that's the best way I found to do it. There are technically ways to do it through Alpine Linux itself, but I've had limited success with that, so I just found that the most reliable is just to use Raspberry Pi OS, which is the first party OS. Alright, so we do see it showing up here, which is perfect. So next thing we want to do is we're going to copy our files from our matching location from the root folder. Now this is on the GitHub site, and it will say root, but we need to download those files and then extract them and then copy them over using a program like WinSCP. So we have this here. I already have it ready to go. So I'm going to type in the IP address. We're going to use port number 22. Username for us is going to be root with our very secure password. I am going to save it out just in case we need it again, and connect to it. I'm going to do accept, which will add it and then hit OK. So right now we're in the root directory, and by root I mean the home folder for the root user, which is this root, not the actual highest parent directory. But we do want to back out to that just to make sure that we're going to be able to copy this successfully. And actually, I didn't go in here. Whoops. Well, here's what we're going to do. We're going to copy it from the other folder. Alright, so we don't have to copy this, which is the instructions, but we do need to copy the rest of the stuff. So I'm just going to select it and drag it over, and it should integrate all of the files within these folders, into their appropriate locations in the other folders. It's not going to overwrite the entire contents of those folders. So we're going to upload 3 files to the remote directory, which is / which is the root of the drive. And that we're going to do. So let's do that. So message of the day will overwrite just because I have one that is a little more explanatory and includes some of the definitions of the settings, things like that, which we'll go over in a second. smb.conf, because we already installed that file, we're overriding the default, which is going to be much simpler and easier to understand and edit. And so it gave us this error right here, and I'll show you how to do that. So we're just going to skip it for now, and we'll retry it in a second. So what happened was we tried to put in a user config file. Technically, we don't need it because our NVMe is already showing up here, which means that it's currently loaded. But let's say we wanted it to run at PCI Express 3, version 3 speeds, which is double the speed of 2, which is the default. So we would need to add that, and the user config has a couple of flags with DT overlays to be able to make that happen. But we would need to do mount -o remount comma, and let me zoom in so you can see this even a little bit better. Remount RW /media /mmc blk0p1. So it's going to remount the base drive, which is usually read-only, so that way we can write to it. And that was the error that we saw. So we go back in here, and when we go back into our files, if we do media, we're going to copy that in, and now we don't get that error. And if we actually look, we see our user cfg.txt was just copied in. Perfect. Oh, we didn't see that. There we go. So here, our user cfg.txt was just added to it. So it does exist. Okay, so now we've copied all of our files. We can minimize that, and now we can set our drive back to read-only. So we're going to remount as RO. Hit enter, and now it's back to read-only, which is how we found it. So now that we've done all this, we could just do lbu commit-d. It's not going to save everything, but save often. It's a good way to go. And now let's go through and just check exactly what else we have to do. We have to add the SMB server share. So we need to add a user, okay? Because we're going to run Samba as the user Samba. So we're going to create a pretty much a service account. So we'll do add user -d -h. So -d means that there's no password, -h means there's no home directory, and the username is Samba. So they won't be able to log in as through shell access. Then we'll give this a password as well, so we can log in using Samba as the username for Samba. And this is separate from the actual login password that they have for the account itself. So it still doesn't let them access through shell. It will only let them access through SMB. We're going to give it a super secure password. Perfect. And it added user Samba to the Samba file for Samba authentication. If we wanted to add additional users, we could do add user, doing the same way. I would suggest doing -d -h if they're not going to log in through shell, just to make sure that they don't accidentally. And then do SMB password -a and the username to set their password as well. So now that we've set this, let's actually add Samba and start it. So we do rc update add Samba. And then the next one, which is rc service Samba start. And we're going to paste that in as well. And we see that it does start successfully. It didn't present any errors that would cause us to have to just go and check. But let's go through and just look at what the configuration file is for Samba really quick. So in /etc samba smb.conf, it's really the minimum, okay? And key thing is workgroup, DOS character set, Unix character set. We're going to force users Samba, so no matter what username they log in as, they're going to show up as Samba. Storage is our actual share. It is browsable, but it is not writable. So it's a read-only Samba share. And the path to that is going to be media storage. But I'll show you in a little bit, but the script is actually, because of it's going through some decryption and things like that, it's actually mounting it during runtime opposed to it being defined through the fstab file. That way, if it does become disconnected or for whatever reason, it will actually automatically recover that as well without crashing the system. So it's just designed to be resilient, but again, you don't have to worry about that. It all happens on the back end. But that's all that's in the configuration file. And it automatically, if we did try and connect to this right now, it would actually show up with nothing because we don't have that share enabled. But SMB is configured, so it would at least ask us for a password. So let's continue with the config. So next we need to build disk locker from source, so that way we can access the NVMe storage. So to do that, we need a few additional packages. So Alpine SDK, Fuse Dev, Embed TLS Dev, Ruby Dev, and CMake. So let's paste those in. Takes a second for it to install, but still pretty quick. And then we're going to clone the code that we actually want to compile. And in this case, I don't know who makes this, but I think this is the main distribution point for disk locker, but always know your source if you're compiling, just because it is something where you got to make sure you trust them so they're not doing anything nefarious with your system. So now we just downloaded it. It put it in the local directory. If we ls it, we see disk locker there. So now we can cd into disk locker, and we can do cmake dot, which is just going to make the local directory, right? So we can ls in here. We see there's some CMake lists, things like that in CMake. So that's what we're going to do pretty much. So it's going to take a second, but it builds really fast. So now it has built that and it's ready to make it. So it's done pretty much the preparatory work for compiling it. And make is going to compile it. So we run make. Right, and there it is compiling away. We see the percentage as it's building, and now it's done compiling. Again, it's not a very big program, so it's pretty fast. And then we're going to make install, which is actually going to install it into our system. And that's it. So now it's fully installed. So we can do a little bit of cleanup just to make sure we're not making a mess of our system, and also save a little bit of space in RAM. So we're going to delete all of those SDKs and dev files that we used in order to build it, now that we don't need it anymore. And that gets rid of them. We're down to the original space that we had before. And we're also going to make sure that Fuse is part of our etc modules file. That will make sure Fuse runs, and Fuse is what's actually used to access the file system. So it's used for a number of things, but in this case, it's all file system related, but it is being used for this. I did not copy it. Let's do that. And I have the if statement just so it doesn't edit more than once. I always find that a good fail-safe. Just if you're writing a script to help yourself, make sure you just put it in so if you do run it more than once, it's not going to break everything. So now we're done with actually building disk locker, and we can move on to adding the necessary permissions to make sure that we can actually run our scripts. So because we just copied them over, they're not going to have executable permissions, which means we can't run them. So we're going to do chmod and do everything in the etc init folder for all the services, and /bin timelapse for all the executables. And all of this is written in Bash, or is written in a readable language. It's not compiled. So we'll go through it in a second after we do get it running, but it is something where you can read it easily. And we're going to do RC update add timelapse loader default. Now, before we do that, which means it'll start with the system, we'll make sure that everything is running first. So making sure it's doing things. So I'm just going to skip this step for now. I'll put a little blue dot next to it. So let's go ahead and just add all of our files to LBU. And this will make sure that it's saved past reboots. And this includes the files that we just created. So the files we copied in, the files that we just created with DiskLocker, there we go. And also the some of the libraries, things like that. Excellent. And now we can do some restrictions on some of the files that we are going to have to edit. So I have some default values for the configuration files, but we're going to set those so they can only be read and written to by root, but not by anybody else. And for the configuration here, this is some examples on how we can configure it. And I'll just expand this a little bit so it's a little bit easier to read. But what we're going to do is we're going to do echo-n and then put our value in quotes and then send it out to the file itself. This makes it so there's no new line at the end or no white space included. And it just makes it so the program's not going to error unexpectedly. So especially usernames, passwords, things like that. There are better ways to do it than I did it, like using JSON files, and I do have versions of this that do that, specifically in a Docker variant, which I haven't shared as of yet. But something to keep in mind, it's a weird caveat with just this particular implementation. So we need to put in a URL, right? So we're actually going to set an interval of 1, not 0. So let me change that here. So it'll do it every second. And actually we could do 0. Let's do the default values. Then we have to do a URL. So the URL that we're going to use today is just this test script. So I have it so every second or every time you request it, it's going to generate a pretty much a JPEG image that has the time. So white background and the time, and that's it. Not the most interesting time lapse, but it will be able to at least show us what's going on. So I'll copy this URL up here. It is a local one. I'm going to paste it into here, just so we can copy it in a bit easier. Then copy this, go back over here, and do the same thing. And I'm going to Control Z on here so I don't mess up my file. Then we have our drive specification. We have to tell it what drive we're unlocking and what partition in particular. So in this case, it's NVMe 0 N1 P2. The way we got that was LSBLK. Just like we saw before, there's two partitions here. One 16 megabytes, which is created by Windows Partitioner. And then there's partition number 2, which actually has the full amount of the storage available. And that's the one that has BitLocker on it. So that's the one that we're going to use. So we're going to use this right here in order to make sure that we're mounting the correct drive. And then here, we're going to put our passphrase. And I'm hopeful I remember it. Let's see. So, a very secure password. I think that's what I put. Again, this is not for production. This is just for demo. I have another one that I built, actually, that I'm planning on using. And we'll commit it. Perfect. Okay, so now we're ready to run. So let's go ahead and actually try running a few things and see if they error. So I'll just clear the screen. So the first thing that we want to do is we actually want to take a look at some of our files here really quick. The main file is Timelapse Loader, and that's the one that we saw we wanted to do the RC update to add as a service. And it has a few options here where you can load the storage, you can unload, or you can launch. And pretty much what it's going to do is if you tell it to load, it will mount the drive and then exit. So let's do that first to make sure it actually mounts our drive successfully. So we'll do Timelapse Loader and load drive. Is that what it was? Or load storage? Load storage. So we're going to do load storage. Okay, it says device not found. We don't have fuse available. So we didn't mod probe fuse. It tells us what to do right up here. So mod probe fuse, if you could see that. Right, mod probe fuse. And if we rebooted, that would do the same thing as well. All right, so now that we've done that, let's try it again. All the other errors below it, we don't have to worry about yet because it didn't do the prerequisite step of unlocking it. Right, so now it mounted successfully. So now if we do df-h, we do see media storage right down here is already running. So, or is already available. So we're using 108 meg out of 477. This is a 500 gig drive. So we're ready to go. So that worked. And we can unload it as well if we wanted to. And generally speaking, that's actually the majority of what we have to do here. Like, that's it. So if that works, we're ready to start it. So remember that command that we skipped that we put the blue dot next to in the instructions? Let's go ahead and run that, and then we can start it. So we see it was added as default. We'll do lbu commit-d, and now we can go ahead and start it up. So we'll do /etc/init.d, timelapse loader, start. And we see it starts. And if we do df-h, we see our storage connects successfully. So it's doing its thing. And if we do screen, because these are running in screen, so that way we can have multiple processes running without having to look at them, -ls, we see there's 3 current running processes. Timelapse loader, which actually launches the other processes and keeps track of them, so if they close, it will relaunch them. And then we have downloader, which is actually downloading the individual files. And then we have archiver, which is archiving it at the end of every hour. And we're not going to wait till the end of every hour, till the end of the hour, but it is something where I think we can, you know, make things a little bit easy at ourselves. But let's look at what we have here. Oops. There we go. Okay, so if we actually look inside of our folder here, right, because it's mounted in media storage, if we hit tab, we see there's a folder called 2024. Right, that's the date. Right, so it's doing year. And if we hit tab, we see 11/11, which happens to be the month and the day. So it's creating year, month, day, hour, which in this case is 4 a.m. And then if we tab into it, we see that it's generating JPEGs, 1 per second. So we do see that it's actually doing something here. And we can go in and look at that particular process by doing screen -r timelapse downloader. Right, and we see it's downloading the images once per second, which is what we want. And we don't want it to do more than that, but it's going to make the more that you download, the longer the time-lapse file is going to be, and it's not going to move as fluidly. It's going to take longer to review. And maybe that's what you want, but I think once per second is usually good, and you can go longer than that and make it so you can condense a much longer period of time down to a smaller period. So to exit this without exiting it, or to close this without exiting it, I'm going to do Control-A-D, and that will pretty much put us back in the desktop and leave it running in the background. Now we still have all of this text here, so I'm going to hit the space key and hit backspace, and it'll get rid of it all and clean up a little bit. Then we see it says we're detached. So that's all good and going. So it'll generate, right now it will generate 3,600 images per hour, which will generate a 4-minute MP4 file. So once that's done, it's going to go, and I'm just going to talk through this, but we're not going to wait for the hour in order to see it. So it'll run Archiver. And pretty much what this is going to do is it's going to wait for the top of the hour. Right, so it's just going to loop forever, but it's going to wait for the top of the hour. And it's going to run through everything, right, last seconds. It's going to track, make sure it's not taking over an hour to process, which would mean it's falling behind. But it's then going to look at the date and generate, some variables, things like that, for what it's currently working on. It will go into that directory, and it does, well, this is going to be hard to read like this, so let's make it full screen here. So I'm going to try and go through this, but it's all in one line. And it's just because it's a consecutive process that's all chained together conditionally. So pretty much what it's going to do is it's going to find all of the individual files within that particular folder for that hour. Right? And for each of those files, it's going to echo file and the file name into a temp list. And the $$ here is actually the process ID. So if you run it multiple times, they're not going to overwrite each other's files, just to keep it discrete. So that's what that $$ means. And technically it's the parent process, but too far in the weeds. So what it will do is it will generate that file list in order, because it has this sort command here. So it'll do it alphabetically, and the way that we've generated the file names is those will always sort in order from oldest to newest. And then it passes that to FFMPEG. And it goes through here, and we're using the concat format, which takes the file as the input name. So we'll go through each of those files, and that will be the input files. Here is where it actually specifies it. We're going to specify the frame rate, so you can actually change the frame rate in the configuration. In this case, the default is 15 frames per second, but you could easily change that to 30 or 60, just depending on what your needs actually are. And it will make it will read those files and put one frame, each of those images will become one frame. It's going to use the codec libx265, and it's going to scale it. So the reason that it scales it is because if the size changes, it will actually mess up the transcoding. So what this does is it looks at the input width, etc., and it will force the output to be that, regardless of what the input is, if it changes during the course of the encoding. So if for some reason your input image changes, it will scale, but it should, whatever that first frame is, will determine your output size. And then we changed the pixel format to YUV420, 10 little endian. Doesn't really matter. It's the pixel format that's needed for H.265 to be really efficient. And then we give it the destination, which is going to be inside of that same folder, but with the MP4 extension on our movie that's generated. If that is successful, it's actually going to go through that same file list, and it's going to remove those individual source files. So all the JPEG images that take up a lot more space than the MP4, those are going to get deleted. And then it's going to clean up after itself and remove the file list as well and echo success. So if it does that, it's not going to delete it. So if FFmpeg fails, that conditional will be broken and it will just say failed, but it won't delete those source files, so you can try again. But if it does, and it generates the file successfully without errors, it will echo success. So if you're inside of the archiver screen session, you'll know whether it's working or not. It will time it and tell you how long it takes, things like that. I usually find that for, it takes about 30 minutes out of the hour to transcode it at about 1.4, 1.5 frames per second. But again, it doesn't have to be that fast. You're just leaving it alone. It just can't take over an hour if it's running every hour. So it's been working perfectly fine for me. You have to wait a little bit for it to be ready, but it more than keeps up with the rate at which it's capturing. And it will tell you if there's no files to archive, things like that. So totally good. And then goes through here, does a few other things. Now, something I'm not going to go over today, but it does have the ability to run in parallel with other processes, with other Pis running the same thing, and they can actually synchronize each other's files. So if you have to perform maintenance on one of them and shut it down, you can actually have it go back through and be able to recover those files so you're keeping redundant copies. So it acts as more of a clustered function. So you'd have two sources that would always have the up-to-date thing, so it's less likely to fail, especially if it's doing security cameras or something like that. And it only takes a few watts to do it, but I'm not going to cover that for now. It actually says it within the login, but it has a little bit of logic associated with that. So that's pretty much what it's doing. So, it goes through, it has, it'll delete the earliest file based on the date. This thing's not particularly ridiculous. And then it'll clean up empty folders, things like that. So that way you're not, as it's cleaning up, you're not misled into thinking there's this many, years potentially of files that are present. And realistically, I found that it's about 700, or I would say about a gigabyte a year in actual storage with H.265 using this method. So it's not very much. You can, with a couple of gigs on a terabyte. With a couple of terabyte hard drive, you can keep a couple of years worth of storage using this mechanism. So it's very clean, very easy, very straightforward, and it is running. So let's connect into it with SMB and actually take a look at it. So I'm using Windows Explorer here. I'm going to do / 192.168.15.140 / storage. And it may have a capital S. Let's see. It may not, though. It's asking for the username and password. Remember, the username that we set up is Samba, and the password is our very secure password. So it's going to log us into there, and we see that we have the folder 2024. We have the month, the day, the hour, and we see all of our files accumulating here. And this one's going to be a very small file because it actually has so much white space in it. But if we open up any one of these individual files, we can see the exact time. Right, so 25 is showing 24. It's within a second or so. Does look like it's a second behind, which is entirely possible because, again, it's generating it. There's some propagation delay, and it's downloading it. And actually, I'm not entirely sure that the clocks are in sync with each other. I may be referencing a different time source. But it's close enough. It's within 1 second. As long as it doesn't drift, that's totally fine. So it's going to keep accumulating these, and if we actually look down here at the bottom left-hand corner, we do see the number continually increasing as time goes on. So as it goes throughout the hour, it will do it, and then it will eventually take all of these JPEGs and encode them into a single MP4 file which will appear in this folder, and all of these JPEGs will go away. And then it will move on to the next hour. So it never actually stops recording. It keeps recording forever, and it will just keep generating these MP4 files as long as it's running. And this will start up automatically because we added that RC update command to start on boot. So we'll make sure that we're all running here. Everything's good. And we can reboot it, we can power cycle it, things like that, and it will automatically take care of everything. And it will also gracefully, if you do the reboot command or the power off command, it will gracefully disconnect from disk locker to make sure that all the writing is complete and that there's nothing cached. So, and if we look at top, the actual download, wait for it to actually time in, is very low. Granted, FFmpeg uses a lot more resources, but again, it's not, during most of the time, it's not taxing any of the hardware, and the power consumption is only a few watts. So, very efficient, and I think it's a great way to be able to use it for just keeping an eye on things to make sure that, if you want to see what people are doing on a computer system, watch a camera and get a time lapse of a street to do traffic analysis, or monitor security cameras at your house, this is a great tool to be able to do that and be able to preserve it and have it be something that you can have that peace of mind knowing without having, and when you do have to review it, not spending an actual amount of time trying to review everything all at once. So it's a lot faster in that regard. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, please share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.